All right. So good morning, everybody. Welcome back to Comp 2452. I hope that you all had a great weekend. I have no idea what the hell is going on with the weather in the city. I mean, I'm from Winnipeg. I was born here. The joke that I like to make is that I haven't gone very far in life because I was born at the Grace General Hospital. I'm sorry, the Victoria General Hospital, which is just like a stone's throw over that away. And now I'm right here. And so I haven't really gone very far in life, but yeah, haha, even pity laughs would be really nice for that. Thank you. I don't know what's going on with the weather today. It is not supposed to rain in January in Winnipeg. That's not supposed to happen. It's supposed to be just cold. It's supposed to be freezing, and we're supposed to be just like complaining about how deeply uncomfortable everyone is with the cold. But well, here we are. Today, what I want to spend some time doing is I want to spend a little bit of time revisiting HTML. Last class, we kind of just raced through this. And so I do want to spend a tiny little bit more time thinking about this idea of HTML and giving you some more context about what each of these different parts are. And to try and give you a little bit of a preview of how this is going to kind of fit into the TypeScript code that we're writing. I believe in Comp 2400, when you were doing JavaScript development, it was purely just like console.log as output and not really interacting with the document object to be able to do stuff with the things that are in an HTML page. So I want to give you a very brief preview of that, but I really don't want to dwell on it for too much time today. What I do want to spend time on today is starting to think about these two ideas, coupling and cohesion. We're going to talk about that before we talk about architecture, but coupling and cohesion, to give you a brief idea of what that is, it's a measurement of how interrelated different things are in our systems. So when we were applying architectures, we were doing stuff that was trying to handle or reduce the appropriate thing here in this idea of coupling and cohesion. And today I want to formally define these terms, and I want to be able to kind of apply those as measurements to the code that we've got in our system. And then finally, we're going to move on to thinking about the model view controller architecture. So I want to give you a sense of, at least in the terms of TypeScript and JavaScript, what each parts of these things are going to look like in terms of code versus HTML versus something else, and how they're going to interact with each other. We'll try to do this with a visual diagram to give you a sense of what that looks like. So by the end of today's lecture, what I want you to be able to do is continuing implement simple graphical interfaces. Again, we'll dwell a little bit on HTML and dwell just a tiny bit on how TypeScript is going to interact with HTML. But that's where we're going to stop today, is just giving you a sense of what those things look like. What I'm going to expect you to be able to do after this lecture is to, again, kind of have a hazy sense of how TypeScript and HTML are interacting with each other and what HTML is. I want you to be able to identify dependencies between components and apply strategies to minimize those dependencies based on the measurements of things like coupling and cohesion. So by the end of the class today, I would expect you to be able to identify dependencies. If I were to give you two pieces of code and ask you what are the dependencies between these things, I'd expect you to be able to tell me what those are. I'd expect you to be able to tell me a little bit about what these things are, the measurement of coupling and cohesion. We'll define what those terms are today in class, but I would expect you to be able to do that after today's class. And finally, what I'm expecting you to be able to do is apply a simple software architecture to an application. So for today, what this is going to look like is apply a simple software architecture is basically, I want you to write code, but before we can get to writing code, we have to start at a little bit of a lower level. So I want you to really be able to define what MVC is. I want you to be able to identify the different parts of the model view controller architecture and describe a little bit what the responsibilities of those different parts are going to be in context of both just abstract what these responsibilities are, but also in the context of the software that we're using. So what is this going to do in terms of TypeScript? What is this going to do in terms of HTML? And how are they going to interact with each other based upon those things? So, like I said, I want to spend a tiny bit of time taking a look at HTML again. Just a brief reminder, because this was about 5 days ago that we were looking at this. HTML is the hypertext markup language. This was initially introduced in the very early 1990s as effectively introduced as part of the web as we know it today. Ultimately, though, HTML is it's a structural language to add meaning. So this is not a programming language. This is just a way for us to describe plain text documents and describe different parts of these plain text documents. Add semantic information. Semantic is the key word here. And semantic, what I mean by semantic is effectively, I'm going to give some additional meaning to what this particular piece of text actually means in this document. So it's going to be that this is something that is meant to be presented with emphasis because I think this word is important, or it can be structural things. Like I think that this needs to appear before this. This is a section that needs to appear before this other section. These meanings that we're getting from this are provided by these things that are called tags. I'm typically going to refer to them by the word elements here, but I may use these two words interchangeably, so forgive me if I do that, but they both mean the same thing in terms of what I'm thinking about. And these tags and elements are hierarchical in nature. So they start with a root element and they work their way down from there. And each of these elements are kind of self-contained in that they will close themselves eventually. What I want to briefly look at here is I want to get a sense of what these HTML documents look like, what this element tag actually looks like, what the attributes of tags and elements are, and what the identifiers are for these elements and tags. So I'm going to pop back to my terminal here, and I'm going to start taking a look at the repository that we initialized last class, the project that we initialized last class. The first thing I'm going to take a look at here is index.html. So again, this is a hierarchical document, and what this is filled with are elements or tags that are adding additional meaning to this document. This document, as it is right now, doesn't really have any plain text in it. There is no real content to this document right now, but there are a couple of major parts to this. First is the HTML tag. This is the root element of the document. This is where everything starts. The root element of the document has two main sections. The header here is going to be the place where there's metadata about the document. So this is information about this whole thing. There's stuff here that we really don't need to care about in terms of what it is or does. The meta char set here tells you what the text encoding is for this document. That's irrelevant to us. We can just trust that UTF-8 is the correct thing, and we can copy and paste that every time we need to make this new thing if we're making a new HTML document. This link is a way that we're showing those icons that appear in the top of the tag, the tab, sorry. So when we open a new tab and we go to google.com and there's that nice G in the corner, this is what's showing that G in the corner, this link rel. This viewport here is describing effectively what the screen is that this is going to show up on. So what is this actually going to look like when it shows up on these things? We're just going to copy and paste this every time we need to do it. We don't need to care too much about that thing. And finally, the metadata that we have here is the title. This is the name of the tab. This is what shows up in the tab name to describe what this tab is. The body itself is going to be where we actually put stuff. This is where all the things are that we're going to show up in the web browser when we open this document up. Right now, there's nothing in this document. The only thing that's here is this div tag. So this div element has one attribute, and the one attribute that this has is an identifier. Identifiers here are meant to be unique to the document. So there's only one of these things, and there should be only one element in this entire document that has this ID that's called app here. This is important to us because ultimately this is how we're going to address different parts of this document when we're starting to build things up with our own code. I want to be able to find this specific element so that I can either put a value in it. Values are going to be the things that are contained within the tags, within the start and closing tag. So if I type this in, this is a value. The text that says this is a value, this is the value that this thing has. This is the inner value of the tag that's called div that has an ID of app. The last thing that we've got here is a reference to the TypeScript file that we're going to be using with this document. So I want to open that up quickly, but there are a couple of things that we've got here. There's the script tag itself, and then there's the attributes here. So each of these things are attributes. This is the type. The type module says, really, I want you to load this as a TypeScript module so that we can start using it as a TypeScript module. And the source here says, this is where this document lives. When you're typing in these things, if you are typing in these paths, they are going to be, I'm going to use the word absolute path. Just quick thumbs up. Do we understand what that means when I say absolute path? Thumbs down if you don't. Okay, absolute path. Absolute path here means it starts with a /. This is the root of the web application that we're working with right now. So when I open my web browser to an address, remember that when we start this, it says something like localhost : numbers after that. We open that up. The / that appears here is relative to the beginning of that thing. It's also relative to the structure of the folder that we have here. So 2452 Iman here is the root of the folder structure that we have for this project. There's a folder here that's called source. And within this source folder, there's a file that's called main.ts. So the / here is an absolute reference to the root of this directory. So starting from there, we're working our way down. I'm going to open up main.ts here. And I don't want to spend a lot of time here. We will come back to this next class and going forward. But I do want to give you some idea of how we're going to find these elements on the page and start to do stuff with them. So this is our TypeScript document. This is kind of the entry point of our application. In terms of thinking about Java, this is the main function. We're starting to execute stuff right here. This is our entry point to this thing. There's some stuff here that should appear somewhat familiar to you in the form of imports, like in Java. They're different because they're not exactly importing packages in the same way that we were importing packages in Java, but they are imports and they are doing functionally the same thing as what we were doing in Java, which is bringing stuff in so that we can use it here. The important 2 lines that I want to focus on are line 23 here and line 5. Line 23 and line 5 are the way that our JavaScript code is going to interact with the web page that we have. There's a variable here that's called document. Document is something that's just in scope for TypeScript and JavaScript files in the browser. This is an object that you can use. It has functions and methods. And the functions and methods are going to give you the ability to ask questions about the document itself. And it's going to give you the ability to get references to things that are in the document. So this one here, this is line 6. It says document.querySelector. We're going to ignore this angle bracket thing here, and we're going to look at this #app. This says, I would like to find the element in the document that has the ID. So # means ID here. I want to find the element in the document that has ID app. What's going to be given back to us as a result of this query selector function is this div right here. It's going to give us access to this div right here. If I go back to this TypeScript document again, what we're saying here, I want to take the thing that's been returned to me. This is a tiny bit of TypeScript stuff here. And I would like to assert that this thing that has been returned to me from the document is of this class, HTML div element. It's of this type. I'm going to make this type assertion. This isn't the same as writing assert whatever. This is going to be, I'm going to tell the TypeScript compiler that whatever gets returned from here is of this type. And so I want to be able to call methods on it of that type. The exclamation point here says it can't be null. I'm going to assert that this thing cannot be null or undefined in JavaScript. And the very last part here is inner HTML. Inner HTML says, I want you to fill the contents of this tag that you've returned to me from the document with that stuff that happens to be in our TypeScript file right now. The same thing is happening down here on this line 18 that I've got. We're doing the same thing, but with this new ID that's called counter. And this new ID has been added to the document by the TypeScript code that we've got. It's this button that has ID counter. And the rest of the line here is doing the same sort of thing. We're getting from the document object. This is a variable or an object that is in scope for our TypeScript file. We're calling this function query selector. I want to get something based on things like an identifier. I'm going to give you this type assertion that it is this HTML button element. This is what the type of this thing actually is. And I'm going to pass the value, this ID of counter. That number sign or hashtag says, this is the identifier for the element that I want you to be able to get from me. The exclamation point at the end says, this is not going to be null. I promise that this won't be null. We're going to come back to TypeScript. We're going to talk about implementation stuff, but I want to give you an idea to let these ideas kind of spin in your head for a little bit before we start writing actual code for this. I want to give you an idea of what this looks like. I want to give you some idea of the terminology that we're going to be using to describe these different parts of the application, but we're not going to spend any time writing code today. Yeah?
So as I said, for example, in case of this tag, the contents in between those tags is the value of that tag, and you can retrieve that element in TypeScript using that value?
Yes. I don't remember exactly what the... So the question is about the value or the contents of the tag. We can get the value or the contents of the tag using something like this inner HTML, but I don't remember exactly what the function or value selector is that we need to use for that.
The contents necessarily has to be just regular text, or it can be like other tags within it?
In this case, what we're doing when we're saying .inner HTML is we're saying that the contents of the div will now become all of the tags and elements that we have in the proceeding statement here. So what we've got between lines 6 here and 22 is a template string in JavaScript. We're basically just dumping that whole thing inside of the div that has that ID. Sure.
What I'm saying is that, as you wrote previously, in between those div tags, some plain text,
Yeah.
and said we can access that element through that tag. I'm saying if that text it isn't just text, it is some other tag.
Yes.
Can access it.
Yes. So there can be other tags. There are child tags. There are children here, effectively. This is a hierarchical tree structure. So in the context that we've got here, the div tag has one child tag or one child element, and that one child element is a P. Otherwise, if we just had text, then it's just going to be, there are no children elements of this thing. It's just going to be the value of the text that's in here. Yeah. Yeah.
Sorry, just to confirm, that's exclamation mark after the
It is so way over here, this exclamation point is an assertion that says that this value will not be null. Yeah. This is a TypeScript thing, not a JavaScript thing. Any other questions about this before I move on? Yeah. So in this case, what it's doing is it's putting everything that's in between those two backticks to say that this is a string template in JavaScript. It's putting everything that's in between those inside of that element. So if I go back to our HTML file here, this div is still going to be here, but there's going to be a bunch of other stuff in it. And the other stuff that's going to be in it is whatever is in that inner HTML like block that we've got there.
We would still have this tag text.
It will still be here, yes. But when we look at the source code in our web browser, and we'll start to do that next class again, we're going to see that there's more stuff now. It's no longer just div with this thing. There might be other stuff in here when we start to inspect the actual state of the document. Yeah.
Just to make sure I understand it correctly, there was a function in main.ts. It's called setup counter.
Yeah.
Accepts whatever element has an ADO counter.
It's going to accept an element, and we're giving it the element that is counter.
Does this element have a type?
The type that it has is going to be this HTML button element. Yeah.
So, what is the setup counter function defined?
The setup counter function is defined in that file that's called counter.ts. I can pop over there pretty quickly. it takes an HTML button element as input, and then it starts to change what that thing should do. So it's going to add some additional behavior. The one important thing that it adds here is this. It adds this event listener so that when we click on it, something's actually going to happen as a result of that. Any other questions? All right. OK, awesome. I'm really excited to do this stuff. I'm looking forward to this because, gosh, I spent some time with JavaScript a really long time ago, and it was awful. It was terrible. It was really bad. It was really, really bad. And so I'm looking forward to spending some time with TypeScript with you this term. All right. And then also, I guess for the record, I am now actually running LazyVim here. And LazyVim, if you're starting to read that book, if you're following along with it, is a lot more approachable than regular Vim is. The papers that I passed around to you, these are for Vim key bindings, and Vim key bindings will still work in LazyVim. Everything that you're doing in Vim should still work with LazyVim. But what I've discovered and kind of like about LazyVim is, one, you can actually click in the terminal and stuff actually happens, which doesn't happen with Vim. That doesn't at all happen with Vim. And the other thing that I like about this is that when you're in normal mode, if you press the spacebar, it brings up this dialog, and it tells you what the keystrokes are for all the things that you want to do, which is way nicer than actual Vim, where actual Vim just doesn't give you any feedback at all. It helps you quit, but that's all it will help you do, is help you quit. So LazyVim is a little bit nicer for Vim work than that. OK, all right. So I would like to spend a little bit of time now reviewing some of the stuff that we did in Comp 2450 with our 3-tier or layered architecture. The purpose of this is to kind of prime us for this idea of coupling and cohesion and kind of give us a reminder of the things that we were doing in Comp 2450 in terms of architecture, so that we can take those ideas and spin them a little bit when we're starting to think about this new architecture that we're working with this term. So what I want to do is just give me 1 second. I'm going to start this Mentimeter here. And just close your eyes. Please close your eyes. Please close your eyes so that you don't see the answers to the things that I've got here. And I'll pop back to my slides, and I'll give you about 10 seconds to join up, and then I'll switch over to Mentimeter again. All right, I'm going to switch over to the slides here. I'll give you like 2 more seconds to join. All right, I got 5 questions about the architecture that we were doing and questions that are kind of around the architecture that we were doing. Here's the first one. That was fast. That was real fast. Good, excellent. The one person that picked singularity, awesome. I don't know what to say other than that. Like, I want to give you spiritual credit, but yeah. So single responsibility principle. Here's our next question. That was really fast. That was really, really fast. OK, all right, OK. So I was trying to trick you here. Forgive me for trying to trick you, but I was trying to trick you when I put dependency injection there. Dependency inversion is the thing that we're thinking about here. Dependency injection is something that we use to do dependency inversion, but dependency injection in terms of solid is the actual thing that we're doing there. This is going to be like tight because everybody answered almost correctly, and it was so fast. So this is just about speed right now. OK, so we'll keep going here. Oragai is at the top, and your boy is in the middle. OK, here's our next question. All right, good. So yeah, our domain model in this architecture, this was what we were ultimately passing between the layers of responsibility. And its main responsibility was effectively just managing itself. It didn't have any other kind of responsibility in terms of the architecture that we were working with. Here's our penultimate question. Awesome, yeah. So our UI layer was responsible entirely for getting input and producing output. That was its primary responsibility in terms of working with the architecture that we were doing in that class. And here's our last one. Awesome, yes. So our logic layer was primarily responsible for coordinating with other classes. So it was managing the state of the application. Like this is where we were putting the logic. This is where we were putting everything that kind of makes our application what it is. But its primary responsibility was coordinating with other classes. I'm going to give some spiritual credit to this one. Yeah, it was managing its own data. It was doing stuff with its own internal state. It was making changes to its own internal state. But ultimately, it was the big coordination thing. This is what was doing all the logic that we had for the stuff that we were doing. All right, I'm going to ask you more questions after this, but we'll take a look at the leaderboard here. This is, again, all up to speed, I think. Okay, congratulations to Oragai, whoever you happen to be. And I'm delighted to see that your boy went up just a little bit and that Android, I think Android is just like a default name. Yes, yeah, yes, question mark. Maybe Android is just following me around from class to class. I don't know. I am going to come back to these slides to ask you this question. Yeah, I still want to ask you this question. That's right. What exactly did we accomplish with that layered architecture? This is the last slide that we're going to look at right now, and then we'll come back to this in a little bit. Separate responsibilities, the S in solid, flexibility, compartmentalizing responsibility, flexibility and reusability, separated responsibilities, separation of responsibilities, modular program design, managing each layer is easier. We were able to swap any of our layers, flexibility, I don't know, distribution of responsibility, organization, interdependency, independency regardless of project, separating responsibility, stress. Okay, fair enough. Reusability, independent layers, reusability, maintenances, separation of responsibilities. Yes, I agree with all of you. The one that I'm really going to focus on here is this word, flexibility. And the other one that I want to focus on here is separating responsibilities. And the main one that I want to focus on here is we were able to swap any of the layers that we have. We're able to make changes to those. Separating responsibilities, flexibility is flexibility. Separating responsibilities is kind of what directly leads to this idea. We're able to swap any of those layers out. The thing that we kind of focused on in my section was we were able to switch out the user interface layer. We were able to take the existing logic layer and persistence layer and slap on a new UI. We started with text-based, but at the very end of classes, we added a graphical user interface and we added a web interface. And both of these were different interfaces to that same logic layer and persistence layer. The canonical example that we never did was we can switch out the persistence layer without having to make any changes to the other parts of our application. We can use a SQL implementation of our persistence layer without really having to do anything with our logic layer, and certainly not with our UI layer. We could make that change without having to do anything with that. So I'm going to pop back to my slides here. We will come back to these in a little bit. But I'm going to pop back here. And what I want to start doing is spending a little bit of time thinking about this idea of measuring interdependencies between layers or between classes or between things that we have in our systems. The layered and n-tier architecture, while I agree with you that yes, it added stress. Ultimately, I think this is a good design. This is a good architecture, and it leads to positive things like I can switch out these persistence layers and I can switch out this UI layer without having to make changes to my application. Each of these different layers have different responsibilities, and we're passing that domain model instances of the domain model classes that we have in our domain model between these different layers. The ultimate goal, again, was to be able to switch out these layer implementations without affecting other layers. We talked a little bit about this idea in class, the idea that the layers have dependencies between each other. And I'm going to make this assertion now. All layers have some kind of dependency. Every layer that we have in our architecture has some kind of a dependency. The UI layer has some dependency on the logic layer. The logic layer has some dependency on the persistence layer. And the persistence layer, while it's at the bottom of the architecture, it still has some kind of dependencies. And the persistence layer in our case was this implementation specific library that was JSON. I want to take my objects and code them into JSON, and I want to be able to read JSON objects and put them back into my domain model instances. So every layer in our application or this n-tier or layered architecture had some kind of dependency. And we were able to do this at the very end of classes. We were able to do things like switch out the UI layer. But how do we know if we're going to be able to do that? I can have an architecture in my application that has a UI layer, and I can have an architecture that has a logic layer, and I can have an architecture that has a persistence layer. But I may or may not be able to actually switch things out easily as we proceed with the development of this application. So how do we actually know if we're going to be able to do that? How do we know if we're going to be able to accomplish this thing? One way that we can figure this out, or at least start to think about the idea of whether or not we can switch these things out, is to start doing this measurement of measuring the degree of interdependence and independence between the layers that we've got. There are two main measurements that we're going to think about in terms of interdependence and independence between these layers. The first is called coupling, and the second is called cohesion. These are the two words that we're going to describe the interdependence between things and the independence of each thing that we have in our system. Cohesion is a measurement of how well some units, I'm going to say pieces of code here, but what I really mean is it can be as large as things like a package in Java. So I'm thinking about Java specifically here. It can be as big as something like a package, and it can be all the way down to a class or a method. The measurement that we're taking here is how well do these things in this single unit, a whole package or all the way down to a single method, how well do each of these little things belong together? How well do they fit together? How closely related are all of these different things so that it makes logical sense to put them close together? Single units here can be anything of methods. So if I have a class that has the responsibility to do input and output, are all of the input and output methods for that thing within the same class? Does this class that I have methods where that method really just has one single responsibility? It does one thing and it does that one thing really well. Thinking back to that single responsibility principle. Do I have a package that is, in our case, labeled something like UI? And are all of the classes within that UI package actually related to the UI layer? Do they have this cohesiveness? Are they related to each other in some way, in some meaningful way, so that it makes sense to stick those things together? The idea here is that we want to make sure that things that are similar to each other should actually be physically close to each other in terms of If this method and this method do something similar to each other in terms of they operate on the same kind of thing, they should be close together. They should be in the same class. If these two classes have the same general responsibility in our application, they should be in the same package. They should be physically located close to each other so that we have this idea of cohesiveness. And this is that single responsibility principle. When we were discussing this in class, we were thinking about it from the perspective of not just individual classes, but as we added these layers of responsibility, it became this layer has the responsibility to do input and output. This is our UI layer. This layer has the responsibility to do all the logic stuff for our application. They belong together in the same package. This layer has the responsibility to do persistence, and it should do that one thing well, and it belongs in the same package. What we would get to if we proceeded with adding the SQL implementation in our Java application is we'd begin to have like sub-packages within persistence, one for SQL, one for JSON, and we would keep those things that are related to each other close to each other. Cohesion as a measurement is something that we would measure as high or low. High cohesion is desirable. We want things that are related to each other to be close to each other, either in the same class or in the same package or in some other kind of unit here. High cohesion is good. This is what we want, and this is what's driving, or this is what is driven by that single responsibility principle. Make sure that each individual thing does one thing and it does that one thing well. If we have one class that does lots of different things, then we would say that its cohesion is low. It doesn't have a lot of cohesion. It's got low cohesion. And that means that it's doing lots of different things. There are different things that are packaged together, and it's not necessarily clear why there are many different things packaged together. So cohesion is measured as high or low. High cohesion is desirable. This is what we want to accomplish, and this is what we're trying to get with this application of the single responsibility principle. Yeah.
Is it a comparison of two things exactly, or like a group of modules or any other?
So the question, I'm going to restate it because I want to make sure I understand it. The question is about, is this a comparison between, can you ask your question again, please?
Like the relationship between them, how dependent those two exact things are. Like it has two operands, or it can have as many operands as we want in order to compare them as a group, like 5 methods, for example.
So cohesiveness is going to be measured in terms of how interrelated the things are. And it can be not just 2, it can be 10 different things. So like I said, if we have a class that has a bunch of methods in it, there can be 15 methods. As long as they're all responsible for operating effectively on the same thing, then that has high cohesion. If we have 2 classes that are kind of related to each other in that they are, for example, input and output classes, they're UI classes, having them in the same package and having 5 classes in the same package, I would say that that has high cohesion then. That package has high cohesion.
We can choose kind of compare either classes or methods, like it works for any kind of approach.
Yeah, so it's kind of something that we can kind of measure at different levels of granularity. So within a class, I'd say that all the methods should have some relationship with each other. And I would say that then that has high cohesion. Within a method, I would say this method does just this one thing, so it's highly cohesive. It's responsible for getting input. It doesn't produce any output that is not related to prompting for input, for example. For within a package or a module, it's all these classes that are within this package or module have some similar responsibility to each other.
We can even determine the level of cohesion for a single method?
For a single method, yes. All the way down to method and all the way up to packages within that or subsystems within the application that we've got. Yeah. Yeah.
Are there situations where cohesion could be interpreted differently based on the goal of the code? Like, for example, if the code is to do ethic A, if this cohesion would be good, but if it was doing, like if the goal was to do something else, like, right now cohesion is sounding a little bit like an objective measurement.
So the question, I'm going to try to repeat it just for the stream and also to make sure I understand it, but I think your question is, can there be different interpretations of cohesion based on different contexts? Where I'm not actually sure what the different contexts might be. I would say that this is an objective measurement of how well together do each of these things fit. And I can't think of a different kind of scenario where you would say that something has high cohesion, but it does 2 different things. Yeah, I'm not sure that I can imagine a scenario where that sort of thing would happen. If you can think of something that's in your head, I'd be happy. Okay, okay, okay. So I would say that this is a pretty objective thing. Like when you're looking at a class, you should be able to pretty clearly understand what its main responsibility is and that all the methods within that class are operating on that same kind of responsibility. Yeah.
I just want to make sure if I so the purpose of this kind of measurement, cohesion and the other
The other one that we're going to get to, yeah.
So their purpose is to kind of assess if our separation in our layered architecture or any other architecture is like appropriate so that we can later use flexibility and the other features.
Yes. So this is being used to measure, should I take this thing that I have? Is it actually two different things? If I can say that this one method makes the cohesion of this class lower, then maybe this method doesn't belong in this class anymore. Maybe it belongs somewhere else. So when I'm using this measurement, the goal is to try to figure out how cohesive it is so that I can make decisions about splitting the code that I've got into other classes or other packages or other kinds of modules. You had a question?
Every class in one package, they would kind of be together, but wouldn't be low cohesion.
I would call that low cohesion if you put every single class in your application in the same package, yes. So when you were doing Comp 1020, I would call all the code that you wrote for that very low cohesion code because you weren't using packages at all. Everything was just in the default package. Yeah. That's a good question. The question is, I'm giving you a binary measurement of this, and I think the question is there something in the middle? So I'm going to say back to this question, it's an objective measurement that we're taking, but you can say that this kind of has like okay cohesion. You can say there's something in the middle. And it might be that, back to this question, maybe there's one method that doesn't belong in this one, but that's going to take a lot of time to break out into its own class because it's used in a lot of different places. And so you might then say, this has like okay cohesion, but I'm not going to change it because it's going to be challenging to do this kind of a thing based on the time constraints that I have right now. I'm going to say that for us, we're going to measure it as high or low, but it might be in the middle in practice. But generally, I'd say binary yes, high or no. This is cohesive or it is not cohesive. I can show you examples of code that are highly cohesive. In terms of low cohesion, I will ask you to use your mind's eye to think about what we might inject into this to make it low cohesion. Yeah. So our other measurement here is coupling. Cohesion is within a unit, within a single method, within a single class, within a single package. Are all of the things that are within that related to each other in some way? Coupling now is how much do classes, methods, modules, concepts, whatever, how much do those things depend on the implementation specific details of something else? This is now measuring across different units. How much does this thing depend on the implementation specific details of this other thing? When we measure coupling, the coupling measurement here is high or tight. These are two words that will be used to describe this concept. And the other is that it's low or loose. This is two words that are used to describe this idea in different places. But low and loose mean the same thing. High and tight mean the same thing. Coupling is a measurement of interdependencies between things. How much does this idea depend on the implementation details of something else? Where cohesion, we want this to be high. We want to have cohesive units in the software that we're developing. With coupling, we want this to be low. We do not really want one method, class, package, module, whatever, to depend on implementation specific details of another one. We don't always want that. We don't really want, as a good example, to depend on the idea that we are using JSON. I don't care that I'm using JSON in my logic layer. I don't want to have the dependence on that implementation specific detail about this other layer that I'm working with. Our goal with coupling is that we want to have low coupling or loose coupling. We want these two different things to be loosely coupled to each other. High coupling makes it hard to change. It doesn't make it impossible to change, but it makes it hard to change. If my logic layer depends explicitly on the idea that I'm using JSON in the persistence layer, it's going to be hard to change the persistence layer later. If my logic layer doesn't care how it's actually implemented, it will be more straightforward to make that change later. While high coupling is bad, we cannot eliminate coupling. This is something that you kind of have to have, otherwise your software will do nothing. It will just be this inert data model that doesn't actually interact with you or anything. It's just going to sit around and do nothing. The ideas that we've been working with in terms of this layered architecture and n-tier architecture is that we can help reduce this coupling between the different things that we've got. This is where I get on a little bit of a soapbox. When I first made these slides, this was an Apple-specific thing, but now it's just all phones. How many people in this room have headphones that actually have a jack that you plug into something? Some of you. And how many of you have USB-C headphones? 4 people. 4 people. And how many of you have Lightning headphones? 4 people. OK, 4 people. OK, so this 1/8-inch jack, that's what we have on headphones. I would unplug my mic and show you, but 1, it would be really tiny, and 2, it would just disconnect the audio feed. And I don't really want to do that. This 1/8-inch jack was a standard for, I don't know, decades and decades and decades, decades and decades and decades. You could take this 1/8-inch jack and you could plug it into anything that had an 1/8-inch jack for audio. I could take these really expensive headphones that I bought and I could plug them into my phone, I could plug them into my computer, I could plug them into my, I'm aging myself here, my CD player or my cassette player, because I did actually have cassette players. And unironically, it was just, that was what it was at the time. I could plug it into anything. And as long as it had this 1/8-inch jack, it would just work. Recently, in the, I don't know, pursuit of slimness of phones, most or all cell phone manufacturers do not have these 1/8-inch jacks anymore. They have either Lightning or USB-C. And that's kind of a giant pain for the people who have spent a lot of money. And now I'm going to point specifically at Apple here. Apple bought from Monster, I think it was Monster that made the Beats headphones. Maybe it was just Beats as a company by itself. I don't know. Apple bought this from whoever owned it before. And I'm not an audiophile, and so you can throw flack at me if you are an audiophile, but these were expensive headphones. Good or not, they were expensive. They cost a lot of money to buy from Apple. And when you bought these headphones from Apple or from whoever it was that made them before, they came with that 1/8-inch jack that you could plug into your phone and your other stuff, and it would just work. But the problem now is that we've got this 1/8-inch jack on our really expensive headphones, but all of our cell phone manufacturers do not have this 1/8-inch jack anymore. When I'm thinking of that 1/8-inch jack, I'm thinking that this is something that has fairly loose coupling. I can plug it into a phone that has an 1/8-inch jack, or a cassette deck that has an 1/8-inch jack, or a CD player that has an 1/8-inch jack, or I can plug it into like a record player if I've got an adapter, because they don't usually have 1/8-inch jacks, they have 1/4-inch jacks. But with my phone, there's nowhere to plug it in. I can't plug that thing in. So while I had this loose coupling with the headphones that were expensive that I bought before, I can't do it anymore. I can't plug it into this device that has all my music on it. We could solve that problem pretty quickly if we got an 1/8-inch drill bit, but that would kind of break our phone. And so now what we have are headphones that are high or tightly coupled with specific devices. When you 4 people have got these USB-C, and when you 4 people have got these Lightning headphones, I'm guessing you use them with your phone and nothing else. Yes? Yes? Yeah, I don't know. What other devices might have USB-C? A laptop. A laptop has USB-C. OK, laptops have USB-C. But for me, this is functionally useless. Like, I don't want to have a pair of headphones that's dedicated just to my phone or just to my laptop. You can buy adapters. An adapter adapter, as we recall from Comp 2450, this is a design pattern. It is literally for this purpose. I want to be able to adapt something that's tightly coupled into the thing that I have that I have in my own system. And so I can take my really expensive headphones and plug them into these adapters. I recently learned, though, and this is a digression, I recently learned, though, that these adapters are not passive. They're not just like passing audio from your device to your headphones. There's actually electronics inside there that are doing digital to audio translation, digital to analog translation, which I was really surprised by. And so different adapters can give you different qualities of audio based on how high quality the DAC is in them. But I mean, ultimately, this is just a money grab. That's what I think anyway. And you can take that for what it's worth. I think that this is just a giant money grab on the part of manufacturers. Do you have a question? Okay.
So we call that the fact that you can't use the 8-inch jack, so we kind of call that high coupling.
I would call this loose coupling.
That's
This is loose coupling, and I'm calling this loose coupling because I can plug it into lots of different things and they will all just work.
So yeah, my question is, doesn't whether we consider it high coupling or loose coupling, does that kind of take into consideration like the standardization of the fact that everything has the 8-inch jack?
Yeah.
Okay, so it's all about the standardization and kind of, I guess, infrastructure, so to speak, of everything else.
With this contrived example, yeah, it's about specifications and it's about standards. So like audio standards, there are certain audio standards that manufacturers lived by for a long time, so that you could kind of replace your tape deck and you could still plug in your old headphones, and you could buy new headphones and you could still plug them into your old tape deck. That is a direct result of saying that everybody has to use the same standards for these things.
So I'm just wondering if that idea of like standardization would apply at all to our coding.
To some extent, yes. So the question is, does this idea of standards apply to the code that we're working with? And to some extent, yes, in that lots of web services, I'm going to use web services. This is not something we're going to do in class, but just to give you an idea, lots of web services will expose data with JSON. They will give you JSON output. There's some interoperability here in that if you have a JSON library, then you can start taking that and you can adapt the domain model that they have in their system to your domain model. But there's some kind of loose coupling in the sense that now it's this text-based representation of those objects in that system. What I am going to say about this, I'm going to go back here, is that while I think that this is an example of low or loose coupling, I don't want to say that there's no coupling here. There is some coupling. Out of necessity, this is a jack that we're using for audio. I can plug it into audio things. I can't plug it into my toaster. That's absurd for one thing, but there's nowhere for me to plug it into. I can't necessarily plug it into other devices that don't have anything to do with what the purpose of this thing is. So there is some coupling here that has some responsibility for saying, I can accomplish this task with it. There has to be some coupling in the systems that we have. Otherwise, we won't do anything with the systems that we have. There has to be some level of coupling. I would like to take a look back at some of the classes that we had in Comp 2450, and I want us to start thinking about these ideas. This one here, I'm going to leave as an exercise for the reader. This is back to your question here. The thing I'm going to ask you, or the thing I'm going to assert to you, is that the classes that I wrote are cohesive. All the classes I wrote are cohesive. All the packages that I put together, they are also cohesive. Inject other stuff in here and kind of convince yourself that that no longer is cohesive. Put print statements in our logic layer. That is no longer cohesive. Put logic layer code into our UI layer. It is no longer cohesive UI layer. Make changes to it that way. So I'm going to make that assertion to you, but I do want to ask you these questions. What are the dependencies between these classes? So we're trying to measure dependencies between classes with this idea of coupling. And does the class then have high or low coupling, tight or loose coupling with the dependencies that this thing has? The first class that I want us to take a look at here is this battle display class. I'm going to go down here. I welcome you to open this up on your own screen if you want to have a closer look at it. But I'm going to scroll down to here. I'm going to give you 10 seconds to take a look at this code. And I'm going to switch back to that Mentimeter and ask you some questions about this. OK, I'm going to switch back to the Mentimeter. And I'm going to ask you, what does this class depend on? What are the dependencies of this battle display class? OK, yeah, good, excellent, yes. The two dependencies that we really have on this class are the battle class, the logic layer class, and the scanner instance. So now my question for you is, I'd like you to rate the coupling of these classes. I'm going to come back to the code. I'm going to go back to the code, so just hold for a second. I'm going to go back to the code. And I want you to assess, based on the code that we have here in this class, and I'm going to go down to the one method that's really in here, the one that's important, I guess, is this fight method. And I want you to determine whether or not you think that this class and this method have tight coupling or loose coupling with each of the dependencies that we have. I'll hold this up for about 10 seconds, and I'm going to switch back to Mentimeter. OK, I'm going to switch back to Mentimeter here, and I'm asking you, does this have tight coupling or loose coupling? I'll hold for 5 seconds, and then I'm going to press the H button to show responses. OK. All right, OK, so this class, this is our display class. This is in our UI layer. I agree with you for this battle, the logic layer that's trending pretty far toward the tight coupling. Yeah, I think this has pretty tight coupling with that logic layer. I'm going to actually disagree with you, and I'm going to say that this also has pretty high coupling on Scanner. Scanner is, in terms of its implementation, when we did this last time, I said, well, we can switch out how Scanner is actually implemented here. We can use files, or we can use like system.in, and we can switch those things out. But that was a dependency of the Scanner class. That was changing the file or system.in implementation of the Scanner class itself. In terms of battle display, the battle display class is very tightly coupled with Scanner. It's super tightly coupled with Scanner. If I want to change that dependency, if I want to change what the actual underlying implementation of Scanner is, not just switch out a file versus system.in, I have to change pretty much everything about this implementation in this UI class. So to me, the coupling of battle display on Scanner is tightly coupled with Scanner. You kind of can't switch trivially from some Scanner input to actually using a buffered reader, for example, to get files from this thing. I don't know why you would want to do that, to be clear, but it's something that you can't trivially do. I'm going to answer your questions in just a second, but I want to also assert that this is essential for the UI layer. We must have this tight coupling here. This is a specific implementation of our UI. I will answer your questions in a second, but I want to go back to the code that we have here in this repository. And what I want to do is I'm going to switch to this battle GUI one. In the battle GUI one, we added this new package that was called battle GUI. And I'm going to tell you that this class, this GUI implementation, it has dependencies on the same sorts of things. It has dependencies on this battle object or this logic layer class. This also now has dependencies on the JavaFX library. It has pretty tight coupling with the JavaFX library. If I wanted to do all this stuff with labels and choice boxes and layout things and prompts and stuff, this is very tightly coupled with JavaFX. It's not going to be straightforward for me to change this to use some other UI library because it's very, very tightly coupled with this specific thing.
Okay, so I just wondered if those two classes, like scanner or battle, if they were implementing some kind of an interface, and we have that kind of an interface there, then that means we can easily replace one with another implementation. In that case, coupling would be low.
So your question is about, I'm going to go back to this code. If we were to change scanner here and battle here with interfaces as opposed to class implementations, would that change the level of coupling? To me, again, I'm going to say that this code is tightly coupled with scanner. If you had some generic input-output interface and you use that everywhere, then I'd say no, it's no longer tightly coupled with scanner. And you could use other things provided you provide those implementations. But in this case, we're depending on scanner's implementation. With battle, the same sort of thing, but the question that I have that comes out of this is, why would we want to do that for our logic layer in this case? In this case, with our UI layer, it's super duper okay for us to have this tight coupling because we're never actually going to reuse this code anywhere else. This code is never going to be used for anything else. I would never really want to use this as GUI code. It is text-based input. It is text-based output, and it's not GUI stuff. So I would never want to reuse this for anything.
Coupling is okay when we know that we wouldn't really change the dependencies?
Yes. Coupling is okay when we wouldn't change the dependencies or when it's explicitly used for this specific purpose. This class does text-based input and output. Yeah. Okay. My next piece of code that I want to show you here, and I'm going to ask you these same questions. Here's our logic layer class that's called battle. What does battle depend on? So I'll hold this up for 10 seconds, and then I'll switch back to Mentimeter. Okay, I'm going to pop back to Mentimeter. Okay. So trainer, yes. Trainer Pokemon persistence, yes. Trainer Pokemon, trainer persistence, trainer Pokemon persistence, trainer persistence, trainer Pokemon, trainer persistence. Yes to all of those things. I'm going to say that no, it doesn't depend on battle state. Battle state is an enum. This is not actually something that has logic. It's just going to be some value that's being used for this thing. If you weren't in my class, fair enough. If you picked that, because it is something that we have in this class. If you were in my class, this was an enum that we built up. So it's not actually a dependency. It's just a data type that we're using in this thing. The main things that we're depending on here are the trainer class, the Pokemon class, and the persistence layer. We're explicitly depending on some persistence layer. And so I'm going to ask you the same question here. I'm not going to show you the code. I am going to show you the code. I'm going to pop back to this code. I'm going to scroll down here a little bit, and I'm going to go to the the attack method, do attack method. I'm going to zoom out just a little bit here, and I'm going to ask you the same questions. So I will hold it right about here for about 10 seconds. Okay, and now I'm going to ask you that very same question. What kind of coupling does this have on each of its dependencies? I'll give you about 5 more seconds to answer. Okay. I very much agree with you, yes. The coupling on trainer and Pokemon is pretty high. It is pretty high. This is a logic layer class that's using these domain model objects. That makes sense for it to be pretty tightly coupled with those two dependencies, with those two class dependencies that we have here. Trainer persistence, I agree with this big lump that's over here. It's not zero coupling. There is some coupling there, But the coupling is on the interface that we have. And this is, I think, to your question in the front here about the idea of replacing this thing with an interface and asking, does it still have a tight dependency on it? The trainer persistence, this is an interface that we defined. The battle class has some dependency on it. It is coupled in some way. It has to call methods on that thing, but it is more loosely coupled than tightly coupled. I would say that this is loosely coupled with that because it doesn't depend on, we're using JSON as an implementation for this thing. It doesn't know or care how it actually works. It just knows that if I call this method, we can assume that some side effect will actually take place. Something will be stored. That's the main thing that we care about from the perspective of the logic class, that is battle. So trainer and Pokemon here, they have high coupling. They are tightly coupled with this logic layer class, but the persistence layer class, it has some coupling, again, out of necessity, but it's not tightly coupled with that persistence implementation. Yeah.
So like, I was thinking that with the implementation itself, it probably has like zero coupling, like very loose coupling. Or like we don't really say zero coupling, we say like loose and tight. Like we don't give values to it.
Right.
Like what kind of coupling is there between our battle and the implementation?
That's a good question. What kind of coupling, how would we rank the coupling between the battle logic layer class and the JSON persistence for trainer? We would say that that has zero coupling. They don't know about each other at all. In that case, they don't know about each other at all. The battle class that we have in the logic layer has a dependency on the interface. It doesn't know what kind of implementation is actually used under there. So the actual implementations that are being used have effectively zero coupling. The coupling that we've got between the logic layer class and the persistence layer has been moved into the interface that we have.
So the coupling, like 3 different types of coupling would be probably like zero, loose, and high.
That's how I would describe these things, yes. Zero between 2 completely unrelated things that may be superficially related by an interface, for example, or just completely different things. My UI classes have zero coupling with the persistence layer because they're completely unrelated and they don't know about each other at all. The logic layer and the actual implementations, they don't know about each other at all, but there's this superficial coupling between them with this interface that we've got. But the coupling is really between the logic and the interface itself. Yeah. All right, okay. I'm gonna switch back to my slides now. What I would like to do kind of here at the end of class is I'd like to introduce us to this new architecture that we're going to be working with. The layered and n-tier architecture, again, I'm just going to assert this at you. This is a good architecture. This is a pretty well-recognized architecture. This is something that in a lot of workplaces, that's the architecture that you're going to see being used in the software that they're building. I think that this is a good architecture. But one place that we want to take a look at a different architecture in this course is that we're going to take a look at MVC. We're going to look at this model view controller architecture, not just for no reason at all, but because this fits better with graphical user interfaces than our n-tier and layered architecture does. This is something that's going to work a little bit more nicely with effectively event-based stuff, as we're going to be doing with our HTML files. This is something that I showed you last term. This is kind of the canonical visual description of the MVC architecture. This originates from the ideas that were put together in a programming language that's called Smalltalk. Has anybody heard of Smalltalk before? Smalltalk is a weird language. It's a weird language in that it is a purely object-oriented programming language. Where Java is an object-oriented programming language. Java has primitive types. It has integers. It has characters. It has strings. And we kind of know that those are not really primitive types in Java, but they're sort of primitive types in Java. But we've got doubles and floats and ints and char. In Smalltalk, everything is an object. Literal integers are object instances. They are not primitive types. They have methods. You can call one dot something if you want to. It's an object in this system. There's a digression, but this idea of model view controller comes from this idea of Smalltalk, where we've got these things that are all objects, and all of these different classes and objects are interacting with each other in some way. I don't really like this diagram. So what I want to do in the last couple of moments here is to draw, or at least start to draw, what I think is a better representation of this model view controller architecture in the context of what we're going to be doing in class here. So I'm going to kill this, and I'm going to start it again. And I'm going to start drawing this out in terms of the way that I think we're going to be using this. So we're still going to have this idea of a model, a view, and a controller. We're still going to have these three different classifications of things in our system. The model, the view, and the controller are different groups of things, so not just classes or code anymore, but different groups of things in our system that each have different responsibilities. The controllers, these are going to be TypeScript. I'm going to put TS here because I'm just going to write TS for the rest of this. We're going to write classes that fit into this controller idea. They are going to be TypeScript files, TypeScript functions, TypeScript methods. This is going to be purely code that we're interacting with. Our model is also going to be TypeScript. This is pure TypeScript in the same way that our Java domain model was pure Java. It's all Java stuff that we're writing here. Our view is going to consist of TypeScript and HTML. This is going to be a combination of these two things. Some of what we're going to write with our view must be TypeScript code because it needs to do stuff. It actually needs to do stuff, and it can't just be inert. HTML as a language, again, it's not a programming language. This is a markup language. It just adds meaning to plain text. It doesn't do anything. It can cause it to look different, but it doesn't do anything. It doesn't do anything. So we have to have some way to have some control over what's showing up on the screen. The view is effectively what our parents are looking at, what we're looking at. This is the presentation. In terms of our three-tier or n-tier architecture, this is approximately the same thing as the UI layer. This is approximately the same thing as the UI layer. The model in MVC is actually the same thing as the logic layer and the domain model put together from our three-tier architecture. Our model will have both model objects or domain, and it's going to have the responsibility of doing application logic. So both of those things fit into this class set now. Our controller is actually something that's kind of weird. It doesn't really fit into this n-tier architecture in the same way that the other classes already do. Our controller here is going to be responsible for coordinating input from the view. When I say coordinating input, what I mean is that our view is ultimately going to call functions in the controller classes. The controller is then going to take the input that's been provided by these UI classes or view classes. These will provide input. And this is usually from a button click. These will provide input to the controller classes. And the controller classes are then going to have the responsibility to make decisions about which model objects need to be updated as a result of the input that's been provided by that button click. So our controller is going to take this input, and then it's going to say, hey, model, you should change. What we're changing here are usually going to be values, but our controller can also have the responsibility to do things like create instances of the domain model objects itself and kind of store them as state. The model is going to have the responsibility then of effectively saying, two things that are listening to it. We're going to have this event listener architecture. The model is going to say, hey, my value has changed. And the view will then have to receive the message and say, okay, I know that this has changed. I'm going to have to change the HTML that is being presented on the screen right now. We'll come back to this next class, but at this point, you should have at least some vague or hazy idea of what this architecture looks like. So you should be able to start to be able to apply this simple software architecture to an application. You should now be able to identify the dependencies between classes and apply strategies. And really, this is about measuring the coupling and cohesion with these things. And again, continuing, you should be able to have some idea of HTML, TypeScript, and how they're interacting with each other at a vague, hazy level. Next class, we'll continue with this idea of model view controller, and we'll start to think about some TypeScript code. That's it for today. Thank you for hanging out with me, and I'll see you on Thursday. Bye, everybody.